Hello, my pilot focuses on the framework for sanitation provision in the urban periphery of Surat or SUDA. The aim of the proposal is to develop a framework for sanitation provision in urban periphery. The objectives include assessing the sanitation situation and outgrowths, to develop a decision matrix for assessing technical options and cost for sanitation provision in urban periphery, and identifying sanitation provision proposals for the selected clusters of SUDA using this matrix. Of the 157 villages, 34 have been shortlisted based on population density, decadal growth rate, and land use, ensuring diversity of the parameters. The six clusters are spread throughout the Suda region. Clusters 1 and 6 are industrial in nature, whereas clusters 2 to 5 are predominantly agricultural and residential. The cluster 5 comprises of the Tena Creek and Barbodhan Lake, hence drawing attention to its unique ecology. For the purpose of site visit and studies, three agricultural villages, namely Kamrej, Barbodhan, comprising of Barbodhan Lake and Masma, were shortlisted along with two industrial villages, Palsana and Vans. It was observed that the agricultural villages had independent bungalows and row houses, which each had individual septic tanks. These were only cleaned when they began to overflow, and the cleaning cost ranged between 6,000 to 8,000 rupees per trip. Although centralized trunk line infrastructure is provided for on the main road of Cambridge, residents are unwilling to shift towards it, whereas in case of industrial villages, centralized sanitation infrastructure was provided in 2015 and newer buildings have connected to it. A decision matrix has been developed to assess suitable sanitation infrastructure options for each village. This has been done in three steps, where the first step the approach is determined, namely centralized or decentralized, and then a suitable technology is recommended based on the weighted score assigned. In the next step, villages and their shortlisted technologies are studied at a cluster level based on the context, which shall eventually determine if a cluster is centralized, decentralized, or hybrid by design. Finally, the priority of provision of sanitation infrastructure is determined based on criteria such as growth rate and population, and hence a timeline is developed. To determine the approach, the criteria include population density, growth rate, distance from existing network, primary and proposed land use according to 2035 DP, which have been assigned unequal weights. This information is to be provided by the user based on which a score is assigned. If it is above 75 for a village, then it is assigned for centralized approach, and if the score is between 0 to 75, decentralized. Under a decentralized approach, the technology is shortlisted based on criteria such as water table, land availability, quantum of flow, reuse or recharge, and required network. The two of the highest scoring solutions are provided to the user along with CapEx, OpEx, and the total area required. Upon assessing the fourth cluster, the decentralized approach was recommended where sludge settling and MBBR was suggested for sludge management and vertical community soak pit for wastewater management. The total capex cost was 7.5 crores and 55 lakhs OPEX, which is to be invested immediately for the high priority village Saroli, which requires 47% of the total investment. Another 40% is assigned for the second phase to cater to the three villages under the moderate category, and remaining 30% to be invested for the two villages under the low category. Looking at the Masama village within the cluster, possible sources for funding include SBM Grameen, which provides 280 per capita for grey water and 230 for sludge management for villages under 5,000 population. Convergence with Jal Jeevan mission is possible as there is water reused and recycled. The gap can further be funded by central and state government grants. Upon assessing all the six clusters, three villages were scored for centralized approach and the rest decentralized. 10 with DWATs requiring 64% of the total investment, 20 villages with sludge settling MBBR and vertical community soak pit making it the most popular choice. 7% of the total expenses is to be spent on the proposed small bore conveyance system. 87% of the capex is required for high priority rated villages, suggesting a strong need for quality sanitation infrastructure. This decision matrix can be used for any Indian city with a rapidly developing peri-urban areas. Limitations include unique characteristics such as migrant population, etc., are not considered, and the existing sanitation infrastructures present in some villages is yet to be considered.